Hi, and welcome to section 3.2. We're going to be working with measures of variation. So basically that means how much do scores vary. So for example, if people were rating a teacher and they said 10, 10, 10, 10, the variation would be 0. But if one person said, oh, I'd give them a 1, another person said, I'll give them a 9, another person said, I'll give them a 2, somebody else says, I'd give them a 10, then that is a lot more variation. But on to this example. So we've got these two students, Jack and Jill. Jack gets 4 out of 10, not very good. 5 out of 10, he's improving but slowly. And then 6 out of 10. Jill was absent and she got a 0 on the first quiz. Then, because she had been sick, she didn't do quite as well as she usually does. She got a 5. And then she was back to herself and she got a 10 out of 10. So if you look at the mean, median, mode, and mid-range from the last section, the mean, if you add them up and divide by 3, it's going to be 5 for each person. The median is the middle score, so that's these 5s right here. That's the same for each person. There's no number that shows up the most, so there's no mode. And the mid-range, you take the biggest number, the smallest number, add them up and divide by 2, and you'll get 5 for each person. So as far as the mean, median, mode, and mid-range, there's no difference. But as you can see, Jack is actually more consistent. He's going up by 1 each time. Jill is less consistent because she's going up by 5 each time. So we need a way to measure and see what number could we use to prove that Jack is more consistent. So here's how we measure consistency. There's actually a couple of ways to do it. Actually 3. So there's the range. That's the easiest way to do it, but we'll find out that it's not actually the most useful. The most useful is this one, the standard deviation. Now what this formula means is you take each score x, you subtract the mean, and you square it. Then do that for each score and then sum them or add them up. You divide by the number of scores minus 1, and then you take the square root. Now I'm going to use the formula just a couple of times. Every time after that, I'm just going to use the good old calculator. Variance is basically the same thing as standard deviation, except it does not have that square root. Or in other words, you just square both sides of this equation and you get variance. Okay, so now let's do that with Jack's scores, which were 4, 5, and 6. So the range, you just subtract the biggest minus the smallest equals 2. Now to find the standard deviation. So the mean is 5. Then you take each one of his scores, 4, 5, and 6, and each time you subtract the mean, subtract the mean, subtract the mean, you square each one, and then divide by the number of scores, which is 3, and 3 minus 1. So this would be 1 squared is 1, this would be 0, and this would be 1 squared is 1. So on the top I have 1 plus 1 is 2, and on the bottom I have 2, so the standard deviation equals 1. And if you look at his scores, they differ by 1. They're going up by 1 each time. The variance would just be the standard deviation squared, so in this case it would also be 1. Now do the same thing for Jill's scores, which were 0, 5, and 10. So first of all, the range is just the biggest minus the smallest, so that equals 10. Now the problem with the range is that it only takes 2 scores into account, the biggest and the smallest. So if Jill had a 0, a 5, and a 10, and then for the rest of the semester she got 10, 10, 10, 10, 10, 10, 10, 10, 10, and 10, her range would be the same, even though she got a whole bunch of 10s in a row, showing that she's very consistent. So the range is easy to find, but it's not the most useful. The most useful is the standard deviation. So start with her average, which is 5, and then take each score, 0, 5, and 10, subtract the mean each time, square them, and we'll get 5. Because this, when you square it, is 25, this is 0, and this is 25. And a 25 plus 25 is 50. You divide that by 2, 50 divided by 2 is 25. Take the square root, it's 5. And then if you square that, that's the variance. So for her, the variance would be 25. So with standard deviation, if you look at these little check marks, a lower standard deviation means less variation. A bigger standard deviation means more variation. So her scores are varying by 5, while his scores only vary by 1. So just a quick summary of that. So the basic definition in words is that if you have the mean, which is in the middle, and all of the scores are very close to the average, then the standard deviation is very small. But if the mean is in the middle and you have a bunch of scores over here and a bunch of scores over here that are all spread apart, that means the standard deviation is going to be bigger. So without actually calculating the standard deviation, which one do you think is going to have the bigger S, or the bigger standard deviation? Well, over here in case A, these are going up by 1, by 1, by 1, and by 1. These are going up by 4, and then 3, and then 2, and then 5. So it looks to me like B is going to be the winner and have the bigger standard deviation. So I put those in the calculator and found the standard deviation. So I'll show you that in just a moment. Okay, so now let's use the TI-84. First of all, I need to enter the numbers. So go right here to Stat, and then Edit, so just hit Enter. Now, I happen to have some numbers left over from some other problem, and I need to erase those or clear those out. So use the arrows right here to go up and down. Go to the top of the list until L1 is highlighted. And then right here, use clear to clear that out. Okay, now type in the numbers 3, enter, 4, enter, 5, enter, 6, enter, 7. So that was group A. And then over here in list 2, I'm going to put the other group 1, 5, 8, 10, and 15. Now, if you mess up a number, let's say that this was supposed to be a 99, you could just highlight it like I did and then type a 99. Oops, that's not supposed to be a 99, that's supposed to be an 8. Okay, so now my lists are in there. The next thing to do is go right here to Stat, move over to Calculate, and we need the first one variable statistics. So just hit Enter. So this is saying right now I'm going to use list 1. Let's say for some reason your cousin was using your calculator and it says list 5 and you don't want it to be list 5. Well, the names of the lists are right here under 1, 2, 3, 4, 5, and 6. There's L1, L2, list 3, list 4, list 5, list 6. So for list 1, you just put second, number 1. For this frequency thing, just leave it blank. Then go to calculate. So the number that we need is the standard deviation. So that's the S. So just ignore the X. S is equal to 1.581 if I go to 3 decimals. Right now my calculator is set to a lot of decimals, so I want to change that to 3 decimals. So just go to Mode, and it's called the float. Just move over and change that to a 3. So now, when I redo it, so go to Stat, move over to Calculate, do the one variable statistics, leave it as list 1, calculate. Now everything is in 3 decimals. So the standard deviation equals 1.581. Now if you need the variance, you just take 1.581 and then right here is the square, so then square it. and that would be the variance, 2.5. Now for the other list, go to Stat, move over to Calculate, still do the one variable statistics. Now change this to list 2. So second, 2. And then move down to Calculate. So the standard deviation is 5.263. And that's how you use the calculator to get the standard deviation. As well as it gives you a lot of other things like the mean, the sample size, and then in the next section we're going to use this stuff right here. All right, I'm back. Here's another example. Which do you think is going to have more variation? The heights of teenagers or the heights of adults? So by teenagers, I actually mean up to 19 years old, and then adults, let's say that's 20 and older. So which group is going to have more variation in their heights? Oh, I should make an on-screen quiz where you click which one you think it is. Well, just tell me, which one do you think it is? So it turns out that it's going to be the teenagers. Because with adults, however much variation there is, there's short people, there's tall people. Well, those adults then have children, which if there's 2 short people, they most likely have shorter children. If there's 2 very tall adults, they most likely have tall children. So whatever variation there is in the adults' genes, they're going to pass that down to the children. So that variation is already built into the kids, the teenagers. The thing with teenagers, though, is some of them, maybe 13 years old, have not gone through puberty yet. So they can be very short because they haven't had their growth spurt. Then you could have a 19-year-old that's 6'5". So the teenagers, because of the idea of puberty, they're going to have more variation. Okay, then on to some important notation that we're going to use for the whole rest of the semester. So X bar, that's a sample mean, and the S is the sample standard deviation. So those we just found with the calculator on the TI-84. So this would be if you had, say, 15 teenagers and 15 adults, then you're finding a sample mean, because 15 is not going to be the whole population. But if you went out to everybody in the United States and you found everybody's height and found the average, that would be the population mean, so that's mu. And this letter right here is sigma. So that's the population standard deviation, if you knew the information from everybody in the whole population. So that notation we'll be using quite a bit. All right, now on to the last important idea of this section called the empirical rule. So a normal distribution means that you've got a bell-shaped curve. I've got a picture of it in the next slide. Hold on just a second. And the empirical rule goes like this. If you take the mean and you add the S, whatever that number is, you add it on. Then take the mean and subtract the S. Well, that is one standard deviation of the mean, within one standard deviation of the mean. So you take the mean, you add on S, you subtract S. So between those two numbers, that's going to be 68% of the data. Now if you do that with 2 times S, so you take the mean, you add on S, you add on another S, you subtract S and subtract another S, you're going to be farther out, and that's going to be 95% of the data. And finally, if you do 3 standard deviations, hold on, if you do 3 standard deviations, that's 99.7% of the data. Now here's a picture of what I was just talking about. So in the middle is the mean. You add on 1 standard deviation to go to the right. You subtract 1 standard deviation to go to the left. That's going to be 68% of the data. More precisely, it's 68.26, but where this 0.13 comes from and where these numbers 68% comes from, that's actually going to be in a future chapter. At this point, we're just getting used to the idea. Then if you take the mean and add on 2 standard deviations, over here on the left, subtract 2 standard deviations, that's about 95% of the data. And then for 3 standard deviations on the left And on the right, in total, that's going to be almost everybody, 99.7% of the data. So here's a real-life example. In the United States, men's heights average 69.5 inches with a standard deviation of 2.8. So what are the two heights where 95% of US men are between? So you take the mean and subtract 2 times the standard deviation. Take the mean, add 2 times the standard deviation. And I'm using 2 here because that's the number that goes with the 95%. So 95% of men in the United States are between 63.9 inches tall and 75.1 inches tall.